Alright, 8th graders, today we're talking about division properties of exponents, and your essential question is, can you divide two powers that have the same base? So, you'll recall that when we were multiplying powers with the same base, for example, 2 to the 4th times 2 to the 5th, all we had to do was add the exponents, and we end up with 2 to the 9th, because this is actually 4 2's multiplied together. And this is actually 5 2's multiplied together for a total of 9 2's multiplied together, which is 2 to the 9th power. Well, division is much the same. We have 4 2's multiplied together, 2 2's multiplied together, and 2 divided by 2 is 1, or it cancels out. 2 divided by 2 is 1, or it cancels out. So what we really have left is 2 to the 2nd power. We just have 2 2's left there. Here we have 5 negative 4's divided by 2 negative 4's. These should have multiplication symbols in between each one. So those two cancel out. I have 3 negative 4's left over. So I have negative 4 to the 3rd power. 7 7's divided by 3 7's. So I have 7 to the 4th left over. So if you'll notice the pattern, instead of adding like we did on multiplication, on division we're subtracting. So 8.5 to the 9th over 8.5 to the 6th is just 8.5 to the 3rd power, because 9 minus 6 is 3. 6 8.5's here are going to cancel out 6 8.5's here, so there's only 3 8.5's left. So 10 to the 8th divided by 10 to the 5th, I think that says, leaves us with 10 to the 3rd. 3 to the 12th divided by 3 to the 4th leaves us with 3 to the 8th. Negative 5 to the 7th over negative 5 to the 5th leaves us with negative 5 to the 2nd power. And 11 to the 4th over 11 to the 1st is 11 to the 3rd. So the pattern is, when you're dividing, subtract the exponents. So a to the m over a to the n gives us an answer of a to the m minus n. Alright, take a look at this set of problems. We have, actually I think you can do this whole set. They're just like the ones I just did. Go ahead and do those for homework. Simplifying an expression becomes a little bit different. So anytime you have the division bar, you want to first do whatever there is to do, either on the top or on the bottom. So here I'd have 3 to the 4th times 3 to the 2nd. So I'm going to take that as a multiplication problem all by itself and do 3 to the 6th. And bring over the 3 to the 3rd. And then I just subtract the two exponents. And my final answer is 3 to the 3rd. Which you can find what number that equals, or I'll accept 3 to the 3rd while we're talking about problems with exponents. Alright, so 2 to the 15th, I can't do anything on the top, but I can do the bottom, so I have 2 to the 8th, because I add the exponents, and then 2 to the 15th divided by 2 to the 8th leaves me with 2 to the 7th. Go ahead and try those two for homework. You should be able to do 1 through 9 for homework. Try those. 10 through 12 I'd like to go over with you. So 3 to the 9th times k is just 3 to the 9th k divided by 3 to the 5th. Now I can simplify this, so I end up with 3 to the 9th over 3 to the 5th is 3 to the 4th, and it's still multiplied by k, so that's my final answer. On number 11, you want to move straight across. So there's nothing I can do with the x. There's no other x's, so I leave x to the 4th alone. Y to the 10th divided by y to the 8th leaves me with y to the 2nd. And 2 to the 11th divided by 2 to the 7th leaves me with 2 to the 4th. And if you wanted to rewrite this correctly, in the most correct way I should say, you can leave it like that. But the most correct way, 2 to the 4th is 16, x to the 4th, y to the 2nd. Actually, I shouldn't tell you can leave it that way. That's kind of giving you a cop-out. So you do need to change your numbers over and actually work them out. If you have a number to an exponent, you need to change it over into the whole number. Alright, and then number 12, a to the 15th divided by a to the 6th gives us a to the 9th. B to the 19th divided by b to the 12th gives us b to the 7th. Alright, so dividing exponents, have a great night.